Hi, AT from CNC at Home. We spent some time at Paramount Granite looking at their large CNC machines, and there was another machine that we weren't able to take a look at. This is a machine that is used to look very closely at their tools after they sharpen them or before they sharpen them. Let's take a look at it. At Paramount Granite, they use the ΩMEGA TMM Origin. It's a presetter for measuring the diameter of their tools. It's one of several in the family. Here are some others. The View, the Exactus, the Helios, and the Solus.
So this particular machine here is the ΩMEGA TMM Origin, and that's the one that they use at Paramount Granite for not only measuring the diameter of their tools, but also looking at the surface of the tool to see how rough it is, essentially. Make sure that it's rough enough, but not too rough. Make sure there's not really any high spots or any low spots in the tool. A cool thing about all these ΩMEGA TMM machines is they are made right here in the USA. All the software that runs these machines is also developed here in the USA. They've got a facility out in Rochester, New York, and I recently had the opportunity to talk to a couple people out in the facility there and find out some information about the machines. They're going to be sending me some information about the entire line of TMM that they have. So that's going to be really cool. And I'm thinking I'll do a video that kind of talks through these machines and kind of some of the major functionality and the differences. So right now I'd like to talk about the Origin that they use at Paramount Granite. As I said, they use it for measuring the diameter of the tool and looking at a profile of the tool as they rotate it to see if there's really any high spots or low spots. The way this works is there's a fixed focal length camera that focuses to the center of the tool, just kind of right on the edge though, so you see a profile. And as you rotate the tool, you just see that particular profile. The software does a bunch of interpreting and whatnot, and it shows you a vertical line then to the high point of what you're looking at, and gives you then the diameter of the tool. So that's really cool. So as you rotate it, you look for imperfections. If it's all good, you get that diameter, you can print it out, and then you go put it in your tool list out on the controller. Some of the bigger, fancier machines will do that automatically. It'll rotate the tool, it'll look up and down, it'll get all the statistics, and it'll interface with your tool list out on the controller and do that automatically. This particular one doesn't have those features. And it's fairly accurate too. Aaron wasn't quite sure what the tolerance were, and the operator didn't know it right off the top of his head. So when I was talking with ΩMEGA, I asked specifically about the Origin, and it does show 4 decimal places, so down to 10,000ths of an inch. And they told me that the accuracy was plus or minus 2 10,000ths of an inch. So that's 0.0002 plus or minus. So that's pretty accurate for just, it's a camera. So that's really cool. So they can turn that and do whatnot. Anyway, why don't we take a look at the machine in action here?
So, if you spin this thing, you can see the camera. You can see the profile there.
Okay, so let's see if I can get this.
You want me to turn it?
Sure, that'd be great, because that's... Wow. And so what's the resolution then of what we're seeing?
I could not tell you that.
Diameter of
The tool, yeah.
But if you move that, doesn't that change as you go? Or maybe not.
I mean, it does a little bit, but
Because that would be its how much.
Yeah, but I mean, even so, I mean, that's going down 4 decimal places.
Yeah.
So we can assume that it's at least 3 decimal places of accuracy, even though it's showing 4. Even if it's only going down to 1,000, it's probably going down to 10,000.
right.
Which would be for machining. That's typically what you're working with is 10,000.
Yeah.
So then for this machine, is it just used? Do you check the tools with it
Yeah, I'll
periodically?
check so every time we dress them, they'll shrink a little bit.
Clean the diamonds.
Right.
So then we'll put them on here and measure the new diameter of it, and then put that in onto our machine.
Okay.
So we can adjust.
So there's like a tool list, and you just say this is tool 1, 2, 3, and its new diameter is.
Like normally this one will go down like this tool is more aggressive, so this one shrinks a lot more. But most of the time, we'll adjust the tools like 5 or 6 thousandths of an inch each time. So.
Okay, so it's a pretty significant amount that you're taking off when you dress those.
Yeah.
Okay. Now, is that something you guys can do here, or do you have to send the tool out to be dressed?
Nope, I do it here.
You do it here.
Yep.
Okay.
Yep.
And is that done on a lathe?
There's a machine that we got back
Oh, it's a
there.
special machine.
Essentially like a lathe.
Yeah.
Okay.
It just spins, and I'll take a stick and.
Nothing fancy.
No.
It's a
Right.
little electric motor.
Yeah.
I'll show you.
Yeah.
Well, even that, I mean, if we're dealing with 10,000ths of an inch, even just an electric motor has to have, bushings and bearings so that it's not wobbling just in its regular
Because
movement.
essentially you're just trying to get this,
The
You're
furthest
trying to
outside point, I guess. Yeah.
trying to
Right.
clean it so you don't have a high spot. Yeah,
It just the machine. The tools will shrink after. We have a flag on them every 600 feet.
Mm-hmm.
It runs on the machine. Then I'll take them off and dress them, and then come in here and measure them.
Okay, and then the
So it's not even
controller.
necessarily the dressing that takes off that much, but I know it takes off a little bit. But
Right.
The
Well, I mean, just
dressing
the
is to
wear.
try to get a high spot.
and to reopen up the diamonds.
Right, and the wear spot. I mean, it's just wear on the tool is going to shrink up a little bit as well.
Yeah.
Okay. And so then the controller keeps track of each tool and how many inches that it's been cutting.
Yep.
Okay.
And then you can send them out and get
EDMs like this one has been.
Mm-hmm.
I don't think I do have a. So this is one when they come brand new. They're that thick. Each segment is. And once it wears down this far, we'll take them off because it'll start leaving a groove on top of the stone.
Mm-hmm.
So then I'll send these out to the company that makes these, and they'll end up sending them back like this.
Right. Okay. So you said they use an EDM for that then?
Yep.
Okay.
Yep. Everything we've tried because we've tried grinding these ourselves here, and we can't find nothing that'll grind this.
Sure.
Because it's the hardest
Right.
hardest thing out there. So
So then, yeah, I mean, there's a vertical adjustment here, obviously, but you guys probably don't really need to do much.
no, I mean some of the
Much of
tools
that.
are different heights, but yeah, I mean it uses the air because it's fairly heavy when you disconnect the air. So
Okay. Interesting. So I mean, it doesn't look like it would be heavy.
not terrible, but it's definitely
Well, the
smoother
air
to
is what
move.
overrides it,
Yeah.
yeah.
Right. And they maybe do that too, just to have more mass, so it's gonna for the actors, it's gonna be less just vibration from us
Right.
stomping around,
Right.
kind of thing.
And you can kind of fine tune it. This is going left to right.
Oh,
that'll go
cool.
up and down. So
Okay.
if you were trying to
Because that's only, that's only getting
hardly
just
any-
a little teeny
Yeah.
tiny slice of the
Yep.
tool vertically. And so with this is all a manual. There's no automated part of this where it spins the tool
There are, but it's
But this
twice as
particular
much,
one isn't. Okay.
Yep.
44,000 for the automated one, and then all the incidentals. So we chose this one. I don't
Yeah,
think-
I'd go with
think it
this one.
was
'Cause this is
17,000.
Yeah.
still that's
Yeah, it's significant.
that's a little more than my my caliper,
Yeah.
which does not go 4 decimal places. That's interesting. So it's not really a picture. It doesn't look like, but it's
It's a profile.
Yeah, because it's a profile. So is it? I'm assuming it's some sort of laser.
It will take a picture. This is
They call it a camera, so I'm
Right.
not sure it's laser.
right.
I mean, just looking at over here, I'm not looking down in it, but it kind of looks like the glow of a
I
red
got a
laser.
video. Go on YouTube, you'll be able to learn all about
There
it.
you go. Okay, so it's the Omega TMM Origin. Okay.
But Omega makes a lot of them for like any kind of machining, so I think
Right.
you'll be able to.
I mean,
You
they're.
can turn on the light if you were looking. I mean, you can adjust how bright it is if
Oh,
you
so it really is a
had
camera.
to see something.
Yeah.
Yeah, you probably
Oh,
like
wow, I
taking a
didn't
video
know
of that
that.
cooler. Yeah.
Yeah, that's very cool.
Oh wow, that's how you can find that high diamond by doing that.
Right.
So if you specifically had one diamond that's off, you can find it, mark it, and go take it off.
Usually if they're sticking out that much, I mean, it's not on this tool, but we have had some other tools. You can see them if you're
See
playing
if
on
they
it.
make it
Yeah.
on,
Yeah. Wow.
The bead.
Okay.
So while other companies might deliver a lot of tech, ZipRecruiter finds you what you're looking for.
this is a position 1.
Okay.
So I'll use a more aggressive dressing stick for that. So they're all 1, 2, 3, 0, 1, 2, 3. I'll essentially sit there for like this, I mean for a couple minutes and just go back and forth. Sure.
Yeah, so this is really low tech.
Yeah.
On this, which you really don't need anything more than that, I guess. So what material is it? So for that first step, what kind of material is that?
It's like a silicone tarp. I can't remember exactly what he said it is.
Okay.
I thought it was a silicone something. This is a little bit, this is still a pretty aggressive wheel, but you can see them fine lines in there.
Oh yeah.
So when our higher number ones start getting those in there, it'll end up leaving them, it'll leave a line on our stone.
Sure.
So we try to get them out using this process, but after a while, they get so deep we can't take them out. So then we'll send them off and give PDF all these tools. So.
Yeah, you can certainly see the groove still in that close up.
Yeah,
But
if you need a diamond ring for your wife for an anniversary coming up, we've got lots of diamonds.
Lots of diamonds.
Lots of diamonds around.
It's not about the size, right? It's the quality.
Well, it's the quantity.
And the quantity, yeah.
We give her an old tool, it's got many diamonds.
Sometimes when we do some really hard stones like quartzite, it'll glaze these diamonds over, and then we'll have to bring them over here and reopen them back up with that.
Okay, so that's kind of like clogging up with the quartzite stuff just kind of gets
so
down
hard,
in
it'll
there.
just glaze these right over.
Okay. So then, I mean, do you end up adjusting the speed on this? Is it pretty much just one setting?
800 RPM is what
800? Okay, 800 RPM on that. Okay.
And these sticks have to be soaked in water. It'll actually soak up water.
Okay.
So you don't have to sit there and spray it the whole time, because it's got to be a little bit wet.
Right.
So
interesting. And you just use water, you don't use an oil of any
I
kind?
use water, and then one of my tool guys told me to mix it with peroxide in there because it softens up the sticks.
Okay.
So.
That was interesting to see how they do the dressing of those tools and keep them in shape for cutting the granite. The granite is a hard material, and even though diamonds are tough, it does wear away at those tools, as we could see. So I'd like to thank Paramount Granite, my friend Aaron, for letting us go and videotape in their shop and showing us around those tools. And I look forward to getting some other tours in at some places, see what kind of stuff's out there. I know that's not CNC at home, but the things that you learn at home on your small CNC machines will translate to those big machines. Oops. Hi, I'm AT from CNC at Home. If you like our content, help support our channel by clicking on subscribe and liking our videos. Thank you for watching this video. Have fun with your CNC at Home projects.